So you're outside and you are throwing a baseball up in the air and it goes up and then comes straight back down again. So if you throw it with an initial velocity of 5.67, so the initial velocity, 5.76 meters per second, and the ball is in the air for a total of 1.18 seconds, so that's going to be our time. We know that it takes 1.18 seconds to go all the way up and then for you to catch it again on the other side. So we have two givens there. We know what our initial velocity is, we know what our time is, and then we also know that if you catch it at the same height that you started from, that y displacement has got to be 0 because the ball ended where it began. That means that it didn't technically go anywhere. The other thing that we do know is if we're trying to find the final velocity, we can look at this as a gravitational problem, and the acceleration of gravity always has to be negative 9.8 meters per second squared in the up and down direction. Now, if I want to find the final velocity at the point that it lands when you catch it here, there are a couple different ways I could do it. There are two different equations we could use, but I'm going to go with the easier one for me, which is the VF equals VI plus AT. I'm looking for that final velocity. I know the initial velocity was 5.76. It's positive because it was going up. The acceleration is the negative 9.8 meters per second squared. And I know that the total time is the 1.18. So if I punch all that into my calculator, I'm going to get a final velocity of negative 5.80 meters per second. Notice that it's negative, telling me that it's coming down. Notice also that because this magnitude is really, really, really close to the initial velocity, it means that I pretty much caught it at about the same height, which means that this is not quite true, because if those were exactly the same, then that would be 0. So then in our next question, how high did the baseball travel? We want to know how high did it go in order for it to go from here all the way up to here. Well, what that does is change our problem just a little bit. So this is going to be a y displacement. It doesn't look very much like a y though, huh? Deleted the wrong thing. So if I put my baseball trajectory back in there, and I'm looking for the y height at that point, then I also know that once you're at the peak of the arc, that the velocity up there is 0 meters per second. So it's slowing down in the positive direction, hits 0, and then speeding up in the negative direction. So in that particular case, I could say that the final velocity equals the initial velocity plus 2 times the acceleration times the position, and then don't forget each of those velocities are squared. So the final velocity at the peak is 0. The initial velocity that I threw it at is 5.76 squared, 2 times a negative 9.8 times y. And then if I square this, take it to the other side, I'll get a negative value that I can get rid of this negative, and then divide both sides by 2, divide both sides by 9.8, and you should end up with the value of 1.69 meters. So you threw the ball about 1.7 meters high. Now, a slightly other different take on this would be, how high is the ball at 0.75 seconds? We want to know at a different time, how high is the ball going to be? And we don't necessarily know where it's going to be at on the parabola here. So we would say that we still know our initial velocity. It's still 5.76 meters per second. We have a time of 0.75 seconds. And we're looking for a height, which is going to be our y value. And we also know that the acceleration is negative 9.8 meters per second squared. So what equation do we have that involves those four variables, or which one does not have the final velocity? That's going to be the position equation. X equals VIT plus 1/2 AT squared. I can say that the position is what I'm looking for. My initial velocity is 5.76 times a time of 0.75 plus half of a negative 9.8 times a time of 0.75 squared. Punch all that into your calculator, and you should get a height of 1.56 meters, which means that it is just slightly below our maximum height here. Now the question would be, are we on this side at 1.56, or be on this side at 1.56? And an interesting thing about our parabola is if it lands at the same height that it began with, then the time up should equal the time down, only in the case where it lands at the same height, which means that half of 1.18 is going to be when the ball hits the top of the peak. So at 0.59 seconds, that's this time here. Time would be 0.59 seconds, which means that if I am dealing with 0.75 seconds, then the ball is going to be on the right side of the peak there. And so that solves all three parts of that problem.